Hello everyone. Let us see what the question says. H2O2 solution 20 ml reacts quantitatively with a solution of KMnO4 20 ml acidified with dilute H2SO4. The same volume of the KMnO4 solution is just decolorized by 10 ml of MnSO4 in neutral medium, simultaneously forming a dark brown precipitate of hydrated MnO2. The brown precipitate is dissolved in 10 ml of 0.2 molar sodium oxalate under boiling condition in the presence of dilute H2SO4. Write the balanced equations involved in the reactions and calculate the molarity of H2O2 solution. Okay. Now the balanced chemical equations. The balanced chemical equations are as follows. Since the question is divided into three parts of reaction, so there will be three equations. For first part, where H2O2 reacts with KMnO4 in presence of H2SO4, the reaction will be 2KMnO4 plus 3H2SO4 plus 5H2O2 gives rise to K2SO4 plus 2MnSO4 plus 8H2O. For the second part, KMnO4 reacts with is just decolorized by 10 ml of MnSO4 in neutral medium and simultaneously forming a dark brown precipitate of hydrated MnO2. So the reaction will be 5KMnO4 plus 3MnSO4 plus 2H2O2 gives rise to 5MnO2 plus 2H2SO4 plus K2SO4. For second reaction, we gave the equation. For third reaction, the brown precipitate is dissolved in 10 ml of 0.2 molar sodium oxalate under boiling condition in the presence of dilute H2SO4. Therefore, the reaction will be MnO2 plus sodium oxalate plus 2H2SO4, which gives rise to MnSO4 plus Na2SO4 plus 2H2O plus 2 moles of CO2. This is the reaction taking place in the above equations. Now, to calculate the molarity of H2O2 solution, to calculate the molarity of H2O2 solution, it is given that 20 ml of H2O2 is given that 20 ml of H2O2 is congruent to 20 ml of KMnO4 or 20 ml of KMnO4 is congruent to 10 ml MnSO4. which again gives rise to MnO2. Now MnO2 is congruent to how much? 10 mole, 10 ml of 0.2 molar Na2C2O4. Now, from the stoichiometry of our reaction, from the stoichiometry of above reactions, 1 mole, 1 millimole of Na2C2O4 is congruent to 1 millimole of MnO2. Implies that 0.2 into 10 millimoles of millimoles of Na2C2O4 is congruent to 2 millimoles of MnO2. Now, also 5 millimoles of MnO2 is congruent to 3 millimoles of Mn2 plus. Implies that 2 millimole of MnO2 is congruent to 3 by 5 into 2 millimoles of Mn2 plus, which is equal to 6 by 5 millimoles of Mn2 plus or MnSO4. Now, also 3 millimoles of MnSO4 is congruent to 2 millimoles of KMnO4. This comes from the equation second. Oh, sorry, this will be 2 moles. This will be 2. This will be 2. 2 KMnO4 plus 3 MnSO4. So, 3 millimoles of MnSO4 is equal to 2 millimoles of KMnO4. Now, which implies that 6 by 5 millimoles of MnSO4 is equal to 2 by 3 into 6 by 5 is equal to 4 by 5 millimoles of KMnO4. Now, same amount of KMnO4 reacts completely with H2O2. Therefore, from equation 1, 2 millimoles of KMnO4 is equal to 5 millimoles of H2O2. It's congruent to 5 millimoles of H2O2. Implies that 2 millimoles of KMnO4 is equal to 5 by 2 into 4 by 5 is equal to 2 millimoles of H2O2. Therefore, now the number of millimoles of H2O2 is calculated, which is equal to millimoles of H2O2 is equal to m into V ml. V is in milliliters because we are calculating here millimoles. Implies that 2 is equal to m into volume is given 20 ml. Implies that m is equal to 0.1. Therefore, molarity of H2O2 is equal to 0.1. Thank you.